Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So let's try to see the problem statement at first for today and then try to understand what it means and what do we need to do. So you are given a zero index integer array nums where nums of I is a digit in between 0 and 9 inclusive. So the triangular sum of nums is the value of the only element present in the nums after performing some number of processes. Okay, so what is that process? You will take each adjacent elements and add them up and perform a modulo 10. Okay, and you will keep repeating this until there is only one element left in the array. So what does it mean basically is that you see this example. Suppose you are given the initial number to be something like 1 2 3 4 5. Okay, so what you do, you create a new array by adding every adjacent elements. Okay, so you get 3 5 7 9, then again you create another array by adding adjacent elements, then again you create, and you go on until you have an element with only one digit present. Okay, and you see whenever you are adding and getting something greater than 10, so let's say in this example you are adding 7 and 9 and getting 16, right? But you need to ignore any two digit numbers and perform a modulo 10. So 16 modulo 10 is 6, so that's why you write a 6 here, and that is why 8 plus 2 is 10, which is modulo 10 will give you 0, so you will write a 0 here, and so on, because only digits should be present in the num array. Okay, so it is, you see, 1000 length is the limit, so you can easily perform a simulation. What do I mean by it? Is that, let's say you are given this array, let's say you are given this simple array of 1 2 3 4 5. Okay, so you can just perform, I mean, in the first loop you can just go till here. Okay, so and you add just this ith element and I plus 1th element. For this last one also you add the ith element and the I plus 1th element to get the new array. So if you add this 1 and 2, you will get this 3. If you add this 2 3, you will get 5, you get 7 after that, and you get 9, and similarly you can just go on. Then now you can just I iterates till n minus 1 here, right? But in this loop I will iterate till n minus 2 because it will go till here. And I hope you can easily understand. 7 plus 5 is 12, modulo 10 is 2, 7 plus 9 is 16, modulo 10 is 6, so and so on. You will just go on performing. This is 8, this is 0, and this is 8. So in the end you will get an 8, and that's what. And you can perform the whole simulation. You see, this will take a total of O of n minus 1, this will take a total of O of n minus 2, and so on. It will go until O of 1. So if you add all the time complexity, it will be nothing but one summation of 1 plus 2 plus 3 and so on. Okay, till n minus 1, and you know this is of the order of n square. Okay, because the first sum of first n minus 1 natural number is nothing but n into n plus 1 by 2. So n minus 1 plus n minus 1 plus 1 by 2, so it will be order of O of n square. Okay, so and O of n square solution will work here. Okay, because this is 1000, so I will just implement this quickly and also tell you the O of n solution, but we will decide on whether to code that or not. So let's try to solve this n problem at first. Okay, so let's try to solve this in O of n square, as I had already told. So you see, we have this n right now with me, and every time let's decrease n. Okay, because in the first iteration we need n minus 1, then n minus 2 and stuffs like that, right? So while n minus minus, I can do a simple thing here, and I will let's not create any separate array every time. Let's modify the array in place only. Okay, and we will ignore the remaining elements. So what I can do is that I can start with this I, and I will go all the way till this n minus 1. So my first will be something like n minus 1, right? Yeah, and I plus plus. And what I am trying to do now is that I will try to do nums of I to be something like nums of I plus nums of I plus 1. I'll take these two elements and modulo it to 10. Okay, so that's what I will be doing, and at the end I can simply return nums of 0, that is all I can do, right? That is all I can do. Every time just decrease this n by 1 unit and just keep checking. Okay, so in the n minus 2th index you will go at first and then just perform this thing, and you just keep on repeating. So you are basically a simulation, you are performing a simulation, that is simulating the whole process what is told in the question, and you are doing nothing fancy and just returning the first element of the array, ignoring the all other elements. So you see you are not using any extra space for this because this space is already given to you. Okay, so any extra space time complexity will be O of 1 because you are not using any extra space, and the time complexity is O of n square. I hope you can easily understand that, and if I try to run this code, it should work just fine, I guess. You see we get the accepted thing, and we also have a 96% runtime complexity and memory complexity. So by looking at this, you might be thinking that there are no other ways to solve this problem, but there is actually. But I will tell you the method, but I will not go exactly into the code of that. But yeah, I will just tell you, because yeah, it involves a lot of mathematics. So what are we talking about exactly? So let's say we have some elements a1, a2, a3, a4. Okay, we have, let's also say that we have a5. So in the first step, if you notice, what are we doing exactly? We are adding the first two elements, then the next two elements and stuffs like that. Okay, so after the first step, we will be remaining with something like a1 plus a2, a2 plus a3, a3 plus a4, and a4 plus a5. This is the thing which we will get, right? Now after you perform one more step, you will get something like a1 plus 2a2 plus a3. What I am doing, I am just adding the next two adjacent elements. I hope you do understand that, right? And a2 plus 2a3 plus a4, and I've added these two. Now if you add these two, you will get something like a3 plus 2a4 plus a5. Okay, now you see, now you try to add the next elements, what you will get. Now there are only two adjacent elements, just quickly add these two and tell me, try to do yourself. Okay, and pause the video and just tell me what is the answer. So yeah, if you see, this will be 3 and this will be 3a3 and this will be an a4, and if you try to just calculate the sum of these two, it will be a2 plus 3a3 plus 3a4 and it will be a5. And if you try to sum the last two elements, you will get a simple 1, 4, 4a3 and not 4a3, it will be 6a3, right? 3 plus 3 is there, so it will be a 6a3 plus 4a4 plus a5. Okay, so this is the last element which you want to return. Now I am asking you to calculate this in O of n time, instead of O of n squared. So how will you do it? So if you, there is an observation, if you see in this, okay, so you are getting the binomial coefficients of the Pascal triangle. So if you know what is Pascal triangle, it looks something like this. So I will draw a Pascal triangle for you if you don't already know this. So we call this a Pascal triangle. We perform something very similar to what we are performing here. We start with 1, then the next element is 11, then the next element is the sum of this 1 and 1, and we always cover our row with 1 on the left and 1 on the right. Okay, now if you try to perform this sum of this 1 and 2, it will be 3, and you cover this elements with 1 and 1. Okay, and you try to perform this 3 plus 1 to be 4, 3 plus 3 to be 6, 3 plus 1 to be 4, you get 4, 6, 4 and 1. Okay, now there are many properties of Pascal triangle. Among the properties, one of the properties is that each element of the Pascal triangle, each row of the Pascal triangle is made up of binomial coefficients. Okay, so binomial coefficients of n minus 1 Ci. The ith element of the nth row consists of the binomial coefficient n minus 1 Ci. So what do I mean by it? So if you try to see if it is the something like you can call it the fourth row. Okay, I am trying to say, because this is the first row by default, so you can call it the fourth row, or if you, even if you just call it fifth row. Okay, so you just call it fifth row. Okay, and you see what are the elements in this. The first element is nothing but 4C0, this is 4C1, this is 4C2, this is 4C3, this is 4C4. So I hope you already know combinatorics from your higher schools. Okay, so yeah, you know this. So what is the answer if you try to see, the coefficient now, it is 1, 4, 6, 4, 1, and if you try to see the previous coefficient, it was 1, 3, 3, 1, 1, 3, 3, 1. So that's what it is happening is that every element whichever, I mean, if you are initially given elements of A1 up to AN, okay, so you can construct a Pascal triangle of AN and you will be given, your final element will be something like this. So let's say n minus 1 Ci. So you will be having something like so let's say this is starting with A0, right? If you consider it like that, your final answer will be something like this, AI and summation of I from 0 till n minus 1. Okay, so you do understand what I am trying to say. Okay, so more or less a similar kind of formula will be there. Okay, so I hope you do understand that this can be solved in O of n time. Okay, so what I can do is that I can simply whatever array is there, I can simply traverse through the array. Okay, and I will take the first element, multiply it by n minus 1 C0. I will take the second element of my array and multiply it by n minus 1 C1 and so on. Okay, I will keep on multiplying, and you see I will also perform a whole mod 10. Okay, I will perform a whole mod 10 also, but you can just break down the modulo and perform singular mod 10 values also. So with single elements you just perform mod 10 values, and if you further decompose this, you can perform a mod 10 of the first element and the mod 10 of the second element and then perform a whole mod. That actually gives you the correct answer. Okay, so now you might be thinking at this point, oh wow, this is a great observation, right? And I can implement it easily. So even if you have understood this at everything till this point, even if you know this Pascal triangle from earlier and you just are looking to implement it, right? But this will not be easy at all. Why I am telling you? Because you see there are 1000 rows. So there will be coming a point where you will be writing the 1000th row of Pascal triangle. And in the 1000th row of Pascal triangle, even if you can know how to calculate the combinatorial values efficiently, you will be getting something like this. This is a very large value. If you see, first of all, calculating factorial won't be feasible at all, because if you try to calculate this, calculating factorial won't be feasible at all. Even if you are trying to calculate this directly, this will go on, you cannot even store this. Okay, you cannot even store this. Now if you try to think that, oh wait, I cannot store this, I cannot calculate factorial, then what I can do, I can calculate the modulo value 10. Okay, now you see this is in A by B format, right? In order to calculate the modulo value, you need mod inverse also. Now 10, you know the prime number, the mod inverse of prime numbers is only defined, because mod inverse, whenever you are doing, you need to take care that your modulo value has a prime number. But hey, 10 is not a prime number, so you can divide it into 2 and 5. So basically, if I try to implement this, you for the last row and for the larger rows of the Pascal triangle, you will need many things. Okay, so you will need to know the concepts of mod inverse mathematics, okay, and all the mathematics associated with this. You will need to know the concept of something known as Lucas theorem, because in order to calculate this efficiently, modulo value of a mod prime number, you need Lucas theorem, Lucas 5 or Lucas 2, you can say. Okay, so what can you do in this way? For this is that, for you cannot do mod 10, right? But you can perform a mod 2. 10 can be written as 2 into 5, right, which are prime factors. Okay, so this can be written as modulo mod 2 and modulo mod 5, and you can perform the inverse mod and everything like that. So you can perform Lucas 2 and Lucas 5, it is known as. Okay, if you don't know this from earlier, it is very difficult to understand. I do agree this. And you can combine the two values of the Lucas theorem using Chinese remainder theorem. Okay, So again, if I try to explain the whole of this mathematics behind it, now even if I directly state you some theorem, you will ask me that what is the proof behind this. Okay, so if I try to make a video which covers all of these mathematics, okay, all the mathematics and the whole thing, a whole implementation of this, it will be at least a 2 to 3 hour video. Okay, if from scratch, if I just show you the proof of all these Lucas theorem, Chinese remainder theorem, and just try to implement this, and I am telling you that Leetcode actually, see, if you see the editorial of the Leetcode for today, they actually do not want you to implement this in O of n square, because this is not any DSA. This is not any DSA concept. Okay, this is pure mathematics. If you are looking for going into mathematics Olympiad and stuffs like that, and I mean, this is not what you should be doing when you are targeting for top tech companies, at least. Okay, because they want I mean, they want DSA from you, not any hardcore mathematics. Okay, so you can put a pause on it, but if you know all these theorems, okay, so then you can just go ahead and try to implement this. Okay, so yeah, that's all, I guess. I hope I was able to make clear at least one of the methods, which is actually very easy and not difficult at all. And yeah, I told you how to approach the whole problem using Lucas theorem, Chinese remainder theorem and stuffs like that. But yeah, that will take a lot of time and a lot of code also. It will be a really long code if you try to implement the whole thing. I guess if you try to find it on internet, maybe this similar problem you will get somewhere which is implemented. So yeah, I will tell you to put a pause here and just prepare the more of the data structures and implementation kinds of thing for your top tech companies interviews. Okay, so yeah, that's all for this video. I will say I will meet you in the next video. Till then, thanks a lot.